Warm welcome, everybody, to our second eSPP webinar today on the 23rd of October. The first one you can already find on our homepage, so if you missed something, just feel free to check that. What are we going to expect today? So it is a webinar that will take hopefully 1 hour. I hope we can stay in the time. It will be recorded and publicly accessible later on the Westernacher homepage or on YouTube as well a little bit later. There will no question and answer interactive section in that webinar, but you of course can use the section and post your questions. We will answer all of that afterwards and come back with an email to you to answer your questions. So you will be set to mute it. The content today is a short introduction, and then we have 4 interesting topics for you today in the pocket. So we will talk a little bit about multi-echelon optimization. We will talk about repair or buy process and the remanufacturing process in eSPP. These 3 agenda points are supported by demos, system demos. So we prepared something in our system. And then I'm happy to have Frank Globisch along with us. He can give us an outlook what comes next at the end of the webinar. And that brings me to the short introduction. So my name is Frank Rohde from Westernacher. I'm a solution architect for SPP and eSPP, or more general supply chain planning. Was involved in a lot of implementations so far that we did, and I'm still involved in those implementations in both areas, SPP and eSPP. Frank?
So hello everyone, good morning, afternoon and evening, depending on where you are on our small little planet. So myself, I'm Frank Globisch, based in Germany, in Gerlingen near Stuttgart. So as Frank already pointed out, I'm with SAP. I have a background of more than 2 decades by now in consulting, all in the area of supply chain planning. And roughly half of that was actually in service parts and service parts planning. I worked and led many global programs in different parts of the world. And now I'm with SAP in the industry business unit automotive, which means I'm working with multiple customers, talk about new innovations, about new requirements, bring new innovations into the solutions, working with our engineering and development teams, and sometimes also with universities in order to bring latest findings into our great SAP solutions. Happy to be part of today's webinar, Frank. Back to you.
All right, thanks, Frank. So going to the next slide, introduction is done. The next point is that we are going to talk about multi-echelon optimization within the eSPP system. As usual for inventory planning, the goal is to generate and ensure stable product availability towards all of our customers, and not losing the eye or the concentration on the cost. So keep the costs low, but availability on all the products should be high. How do we do that and ensure that? That is actually the calculation of the safety stock. That is a piece of or parameter that can ensure that. So we are talking today about the calculation of the optimal safety stock and the economic order quantity, so how much we order. And SAP offers, or SPP offers, or eSPP offers 2 approaches to that. That is a single echelon calculation of the safety stock and the economic order quantity. Within that approach, the parameters are going to be calculated independently from each node of the network. So for each single location, these values are calculated as a mathematical optimization exercise, comparing the procurement costs and the stock holding costs and trying to find the minimum pair of safety stock and economic order quantity that is then the result of this optimization. But we don't want to focus too much on this one today. We would like to introduce you to the multi-echelon safety stock calculation within eSPP. And the big difference is that this algorithm or method is not only calculating how much stock we should keep in each of the location, it's helping us to tell us where to keep the stock in the network. So it's not looking into each single echelon, it's really considering the whole network and trying to place the safety stock where it makes most sense. The EOQ is calculated separately and not together like in single echelon optimization based on the classical ANTLA formula. So there is no magic behind that compared to the safety stock calculation. Short reminder, I will keep it short. The single echelon approach has certain input parameters, so procurement cost, ordering cost, stock holding cost factor, lead time, service levels, and the forecast, of course, is an input as well that we need. And I want to point out that the forecast error is a standard deviation here. And then the system is doing iterations and trying to find the best combination of EOQ and safety stock, which is used later on in DRP and deployment. In opposite or difference to that approach, we have the multi-echelon. So here really the system is considering not only each single echelon, each single location, it's trying to incorporate the impact of all echelons in our network. We have input parameters, of course, as well, the stock holding cost factor, the lead time, and the target service level, mainly for the facing location. We have, and we will see it in a minute in the system, we have a range of target service level for the non-customer facing locations. Replenishment indicator forecast of each single echelon and location is considered. The forecast error is calculated a little bit different in that algorithm. That is a coefficient of variation and not the standard deviation. As an output, we do have the safety stock, the same output as in single echelon, but on top of one single value, the multi-echelon algorithm gives you the portions of the safety stock. So where does the safety stock come from? Does it come from the demand variability? So that means forecast is not 100% correct. So there is an uncertainty in the forecast that leads to a certain amount of safety stock that falls into the demand variability share. Our parent location is not always possible or able to deliver all the products I need on the customer facing location to fulfill the customer demand. That portion is mentioned in a separate key figure as a service variability share of the safety stock. And you see here a third one, that is a supply variability share. That is in a different color because we don't see it in the demo, because that is an additional portion of the safety stock that gets introduced in the last release from SAP, which is out 2 weeks, or which came out 2 weeks ago. And we don't have it in our system, as simple as that. And that comes from the lead time variability. So lead time has a certain uncertainty as well. And that portion of the variability is shown separately. And then all three key figures together will give you the final number for the safety stock. EOQ calculation, we have as well the inputs, and we apply the standard ANTLA formula. We calculate EOQ. There is no connection between those two values as it is in single echelon. All right, as simple as that. It looks quite simple in the system. The background algorithms are not that simple. What do we see in the system today? So we will show you a 3-level BOD, and we will calculate, or it's already there, the safety stock and EOQ values on a single echelon approach. I will show you the parameter details, lead time, stock holding cost factor, and so on, that are inputs and considered. And then we simply switch to the multi-echelon and execute the planning service. And then we again go into the EOQ and safety stock UI and the planning UI, and I'm going to explain you the differences, the new key figures, and then we have a short variation of it, and we adjust the target service level, the range of the target service level, and we will see the effects of it. So that is what we are going to show in the system. Saying that, I'm switching, and I hopefully did not get locked out. It looks like that I'm still in here. That is the Fiori Launchpad that the planner usually sees with all the applications, instead of the standard GUI, which I have prepared here as well. But I'm trying to execute all the stuff via the standard Fiori app, which is the standard tool to use actually. So I'm going to start all the transactions in the new tab that we can switch back and forth. So I'm opening the inventory planning book, and the demo is on a certain product. And we do see the BOD where the product belongs to. So it's a 3-level BOD with a lot of locations in it. And if we double click, let's say, location SPP4, which is a customer facing location, it's on level 3, we see what the system calculated based on single echelon for each of the months. So we have the economic order quantity, and here we have a location's own safety stock of 8.22. And we see further key figures. Probably important is the demand and the standard deviation as well. So of course there are more, but they are not really important at the moment for this scenario. If we scroll down, we have some other attributes and parameter that will influencing the safety stock calculation. So the lead time, of course, is a portion of it, flows into that. The stock holding factor, fix the ordering costs and the procurement costs as well. And as a planner, or the limits, we see that the target service level for all customer facing locations in our scenario is set to 95% at the moment. So I'm looking into the script. So that's probably it, what I wanted to show you as a beginning. I haven't prepared the target service level. I can go into the UI. There is no Fiori app for it, because that is the planner normally is not doing the changes in here, and I'm just pulling out our product, because we have, of course, target service levels and multiple products in our system, and I want to of course want to only not confuse you and only choose our product, which we see here, and we see all the locations. And for example, if we go to the SPP4, we see we have this 95%. And let's say if we have the entry location, which is SPP0, there we see we allow a min and a max target service level. So we allow between 50% and 99% as a target service level, which comes into the picture when we run the multi-echelon optimization and let the system find out what the optimal service levels or safety stocks are, and then the system can vary the service level of the non-customer facing locations. Saying that, I'm going back to the system actually, and now we change the settings for the product and we say we want to run now multi-echelon for this product. So, and we simply change the material eSPP 015, and all we need to do is switch one parameter from eSPP calculation inventory planning mode, that is a single echelon optimization, and we go to multi-stage safety stock calculation service and we save it. So that is adjustable for each of the products. And now we simply need to execute the planning service for multi-echelon optimization. And that is normally running completely in the background. We now, of course, need to trigger that manually. That is set up in the background, so we execute it. And hopefully the system will now apply the multi-echelon logic compared to the single echelon logic. So, and what the planner normally is using this Fiori app. I want to start that in a separate box as well. So, and here we have different areas. There was another webinar or video where we explained that. So, and if we go to safety stock approvals, we hopefully will see, okay, our product now got consumed by the planning service. And here we have the old safety stock. The planning service was running with approval, manual approval. And here we do see the proposed new safety stock. And we clearly see that the safety stock got moved or increased on the customer facing locations, which are level 3 locations, SPP 3, 4, 5. So there we see an increase of the safety stock. And on the intermittent parent, like the entry location or SPP 1 or SPP 2, we see a decrease. So the system generally tries to bring the material closer to the customer because that is more efficient from the planning point of view. How does it look like? Because it's not approved, it's just proposed. How does it look like in the planning view? We simply go back and load it again and go to SPP 4. And now we see additional key figures here. So we have temporary key figures. So we have EOQ, we have safety stock, and we have the different chairs for the safety stock. So the demand chair and the service chair. And they are, because they are not approved yet, they are shown here in parallel. So here on each location, we see as well, location's own safety stock is 8.22 actually, because we didn't approve it, and it will go up to 14. And these 14 are split or based on the demand variability. So forecast is probably not that great, and the service chair variability. So how much our parent location can deliver to the customer facing location. So, and as long as we don't approve it, we will see all of that in each of the locations. So if we go to the entry location, we see as well that the safety stock of 109 was it before. Now we have actually 0 because we have moved most of the safety stock closer to the customer. So if we go to the planner's work list and we say, well, that makes sense, we simply approve it. everything is approved. And now we can go back to that one here and refresh it. And we will see that now the temporary key figures are gone because we approved it, and the new information got moved to the final key figures here. I forgot to compare the absolute numbers, but I wrote them down in the presentation. So the single echelon was leading to 180 amount of safety stock in the whole network. The multi-echelon now, and you see here the same numbers. So we were in SPP 4 in the system that changed from 8 to 14. And the 109 changed to 0 on the entry location. So we adjusted just by applying this planning service. We are almost half of the safety stock in the system. Do we like to have no safety stock on the entry location? Most of the customers I know don't like it. And of course, that is because of our settings. So as a last variability or change here, I simply tell the system, well, for my entry location, please don't vary the target service level between 50 and 99%. Just go on the entry location with 90 and 99%. And when we now, just with these settings, run the safety stock planning again. So we simply execute the same planning service. I need to look a little bit after the time. Ended successfully. I go again in the planner's work list where the planner see and can approve the results and push the refresh button. And now this system, just because of our slight change in the target service level variability on the entry location, it changed again. So the safety stock that we had before was this, and now we have this. So now again, the safety stock is split differently in the network. So we have on the entry location 75 pieces of safety stock, and we lower a little bit on the customer facing locations. So that is the simple effect of the right parameters, and you can really control and steer in the multi-echelon. So I could make a demo a full hour or even longer. We can vary the stock holding costs, we can vary the lead time. So all of these parameters will lead within optimization to different results of your safety stock in the network. But all variations are always below the single echelon. So the second this variation, if you add those numbers together, you will end up with 112.7 pieces in that variation. So still 70 or 68 below the single echelon. So the message here really is that if you have larger networks, it really makes sense to implement multi-echelon. If it's an easy BOD with only 2 levels or 3 locations, then the optimization is not that important. But as long as we switch to bigger BODs, it totally makes sense to switch from a single echelon to a multi-echelon approach, and that clearly shows that you can by the same service level you can reach lower safety stocks. I didn't compare.
Right. And that's exactly why we also said, okay, we need to give such opportunity to save money and save investments to our customers. And that's why we had brought in this new multi-stage optimization, and I'll come to that later in the outlook, that we are working on even a further enhancement on that, because we see that this is a big value driver for our customers as well. But with that, back to you, Frank.
So I need to hurry a little bit if we want to stay in an hour. So the next process is not presented quite often so far. That is a repair or buy process in eSPP. So it is counted from my point of view as an alternative supply option. So instead of buying the new products, we really can repair it. And this process helps you to answer the question, should I repair a failed part or should I buy a new part instead? There are certain benefits. They are more or less clear. I will skip those ones. And how does it work in eSPP? There is no special planning service to that. That is fully integrated into the DRP process. So DRP process is distribution requirements process. So everything that process is doing is trying to find out what is the demand we need to place against the supplier. And in this case, it reduces the demand and creates repair orders instead. So it's considered during the net demand calculation and resulting in planned orders to trigger the repair of those products. If repair is not sufficient, it will create a purchase requisition to procure that part from the supplier newly. How does it work? From the eSPP perspective, we have, again, certain inputs. Of course, the standard inputs that you always need for DRP as safety stock, forecast, economic order quantities, pack sizes, and so on. And then we have additional parameters that are considered. So we do have a return rate. So how many products are coming back from the customer, in which time frame they are coming back, how much of the returns can be repaired, what are the costs for repairing it, what is the repair time and the repair type. So that are the main inputs from our system setting. And of course, we have as an input the returned quantity from the customer. What is DRP doing then? So it calculates a return forecast, and then it's doing a net demand calculation, and it's creating confirmed receipts for the repair. So any planned order for repair is, from the planning point of view, considered as a receipt, of course. And if that is not sufficient, it will propose a new buy for this product. This is the execution process flow, not so important for the planning point of view, but of course, these are the steps you need to consider in the execution, because planning will not repair the products, planning will not scrap the products, planning will not send the products back into the supply chain. So all of that is more or less an execution topic that needs to be designed along with the setup of the planning service. What is the concept behind? And important to know, that works with a single material number. And that is compared to the third process I'm explaining later on, important to mention. And at the end of the day, we have unserviceable parts that we can repair. Then we have the repaired parts that are more or less serviceable then, because they are repaired, and we have new parts that are serviceable parts as well. The question is normally that I'm getting is, how does it work with a single material number? We do have different storage locations for the serviceable and the unserviceable parts. That is the answer. And we will see it in the system as well. You can choose from different business scenarios in the system, so only repair, or so not combined with a buy, or repair or buy unconstrained, so there is no constraints on the repair capacity, and we can have constraints on costs or capacities or even timeline. So these are the more or less options or the concept behind, and not too many slides, as I said. We just want to go into the system and see how it's working. So we will show you a normal product, how DRP look like, and then we change to repair process for that product, and we will see how DRP is reacting on that decision that we want to repair this product. So then we can compare the both DRP runs. Saying that, let's jump back into the system, and well, yeah. So let's open the DRP matrix for our product. I'm going again over the Fiori apps. I close the ones we had before. The DRP matrix is no, it's not open yet. So on my Fiori apps, my favorites have the DRP matrix. So we have a different product now that is product number 17. If we go, so you do see a little bit of different BOD in our system. So it does have 3 levels, but not that many, or a different structure of it. So we have more level 2 locations than level 3 locations. Saying that, we go to the DRP matrix and see what the system would calculate. We have different key figures. So if you're not familiar with the DRP, don't get scared by all these key figures. I will point out the important ones. So we have initial warehouse stock for that product 995. And if we push the simulate button, we will see what the system is trying to order for that product. So we have a certain gross demand. Then we have no receipts yet. And the system is calculating based on the demand and the initial stock when we need to order. So in this case, we need to place an order, or we want to have materials on the 31st of October. And if we scroll to the right, we see even more orders that we need. So the net demand is calculated, and this quantity would be the quantity that the system would order. Switching to a different mode, check it in months. That is important to compare it later on. So this line shows the monthly demand actually for this product. And what we now simply do, I duplicate the tab that we see it again because I opened that. I need to keep that going back. So I need to keep this DRP matrix. And now we are, what we are doing, we simply change the planning process for that product number 17, not 15. And we tell the system, well, yes, now we want to start a repair cycle for this product. And we simply go into the system and tell the system that we are going to switch on the repair cycle for it. So repair or buy. And here are the parameters that are inputs and mentioned before. So we have the return rate, we have the yield rate, we have the repair cost. So all of these parameters then will be considered, and they can be maintained via each product location if they are different for each location and on each product. So we save the data saved, and now we simply execute and run the DRP matrix again. So for that product, we push go button and we go to the entry location. And now, compared to that DRP matrix, we have an additional key figure here: unserviceable available stock. So just by activating it, the system noticed, well, I need to look into a different storage location where my unserviceable parts that I can repair are laying. And that is what we do have here. So on top of these 995 of the projected stock, our initial stock, we have now 150 pieces that can be used for repair and can contribute to our demand in the supply chain. So now the next step is we simulate now we switch back first for this one here to days in order to see it better. So now we have on daily buckets DRP, that is a normal behavior, and now we simulate with this flag activated. And the result we will see is different. So now we see that we have, if we open that key figure, we have a repairable returns forecast. So the system is calculating how many materials I'm getting back, how big is my repair rate, and how many materials can be used instead of a new buy. So that is one point, and when we close that again, we will see that we have confirmed receipts. So on that day, we get 214 pieces repaired back into our supply chain, and that is lowering our rounded net demand because we don't have to order so much anymore. We do have to order only 161 instead of 482 pieces. And if we go to the monthly view with this repair and we tick mark this line, which is my demand for the new product I need to buy, we really see, compared to the DRP metrics here, that is tremendously less. So because we are using the repair parts. Saying that, all we did was simulation so far, and now I simply execute that, and we hopefully will see that we generate planned orders to trigger the repair, and we generate purchase orders to trigger the new buy. So I'm executing that now online. That, of course, will be executed automatically in the background, usually during a night run. And when the planner comes in the morning, he sees the results. So then I open the DRP metrics again for the product. And now I go in the schedule maintenance board for this product and see what the system did generate actually. So now we clearly see that we have purchase orders and planned orders for it. So we have purchase orders that we need to procure, and we have a planned order of 214 for that product that is now triggering the repair. We have a purchase order here for the new buy, and we have several planned orders to trigger the repair. And the system is trying to do everything with via repair based on our settings. And I think later on here in February, the repair capacity is not enough. So there we need to procure again 161. But the rest is all covered by the repair, and we generate the planned orders for repair. So it's actually as simple as that you decide to repair the material, to change a flag, and then of course the process of repairing needs to be in place. so and all the execution side, but the system fully automatically executes the comparison with the repair part with the new part and trying to use the repair part based on your settings. The next process, the alternative to repair or buy, might be remanufacturing, which is as well, from my point of view, an alternative supply, because we try not to buy something, we try to remanufacture something. The aspects of sustainability and the benefits are mainly the same, so I keep that short. I only focus on the procurement proposal. So this is always resulting in a procurement proposal, either for the remanufactured part, because that is an external supplier that is doing the remanufacturing, and we need to procure this part from this supplier, from this remanufacturer, or a new part will be procured. Process starts a little bit differently and has different inputs as well. So the customer is placing the demand for the remanufactured product. he probably doesn't even necessarily know that we remanufacture that product, but he places a demand for this product. And we have, of course, safety stock forecast EOQ for this product, and we have a remanufacturing chain created for this product and for the new product. I will show that in the system in a second as well. We have a certain DRP profile that tells the system, please consider the remanufacturing chain, and we have supplier capacity information in the system. Time-wise, it's fine. So DRP runs as normal and is considering if we set up this, or we set up the service profile in a proper way, is doing the net demand calculation, and whenever something cannot be procured or remanufactured, it's creating substitution orders for the new part that are leading to a purchase requisition or schedule line entry or whatever. And of course, you have to have this execution process flow in place as well. Simple example that makes it more clear. Customer needs 100 pieces of part XYZ next month, and we do see that demand from planning. We see next month we will not have the part available on the location that is supplying this customer. We have the new part available of 20 pieces. Then the system would proactively say, okay, let's try to cover that demand from the external repair supplier or subcontractor that is doing repair. He has a constrained capacity of 60, and therefore we try to use all his capacity, but that is not enough to fulfill the 100 pieces. Then the system is create the alternative purchase order for the new part. We get those receipts, and then we would deliver 60 pieces of the old part or the remanufactured part and 40 pieces of the new part. And in order to make that happen, we simply need a remanufacturing superset or chain where the old part or the remanufactured part is the predecessor and the new part is the successor. I hope that makes it clear. And this concept or this process works with two different material numbers that are connected via a remanufacturing chain. That only works for with external suppliers or subcontractors that are doing the remanufacturing for us. And the system, there are different checks, and the system always is trying to use the remanufacturing capacity to fulfill the demand. Only if that is not possible, the system will create a purchase order for the successor part of that remanufacturing chain. In this system, I will show you the supersession chain. I will skip. Both have different external suppliers. I will skip that. You need to believe me that we have different suppliers for it, a remanufacturing supplier and a supplier for the new product. Then we will go to the DRP matrix and see what the system is doing out of this, and we will see the substitution demand. Saying that, we jump again into the system. This time, I need to switch my script a little bit so we have different products again, and I would like to showcase or to show the simple supersession chain. I open that in a new tab. So that is a supersession chain that we need to maintain. So we have the eSPP 010 as a product. And if we push the go button, we see, yes, there is a product substitution existing. The predecessor is the 10 and the substitute product is the 11. If we go into that, we see that this is not a normal supersession chain. We see that is a remanufacturing product substitution. So that is a key point that is different to the supersession chain, which we generate normally through this UI as well, but with a different type. So it's eSPP relevant. We have the use-up strategy, yes, to maintain. So it's as simple as that. creating. It's valid from the 10th of October. So a valid supersession chain of the remanufacturing part with the new product. That is all that we need. And
by the way, what you just saw now as well is already the new supersession object that is there in S4 since a couple of releases, where eSPP is fully supporting that together with AATP, so that there is again a close tie and integration between those two different modules for our service parts execution. Back to you, Frank.
Yep, thanks for the adding this, and that is true, and it's much more handy than the supersession in SPP, if I can say that. So we go to the, so I don't showing the supplier capacity and the different supplier products, so that the supply capacity is uploaded to a time series shared by the supplier that is doing the remanufacturing, and we simply go to the DRP metrics for that product and looking how it looks like on the entry location. We push the simulate button. We are still in monthly buckets. I would like to switch to daily buckets. No, it's not test. It should be this one. And I push the simulate button again. We see that that we don't really have any gross confirmed receipts in this situation. So all the demand can be covered by our remanufactured product. So we can scroll to the right. So all the demand that the system and the customers are generating can be satisfied actually by the remanufactured product. That looks a little bit different when we switch to monthly buckets. And I'm going to tell you why, because here in April and in July next year, we see, oh, there is a confirmed receipt. Where does this come from? And if we go to the unrounded net demand, to that key figure here, we are always in the months before below our capacity constraint of the remanufacturer. So he can remanufacture 2,000 products per month. And in this month, we are the first time where the demand is higher. Here is a second month where the demand is higher. So the system now sees, okay, I cannot fulfill the demand for this product just by remanufacturing it. Therefore, it creates substitution orders. So it tells us that in this scenario, we need to substitute the remanufactured product with the new product because the demand is above what we can repair. If we double click on it, we see where this demand comes from. So actually on this location, we have a demand of 11.5 pieces for this product that cannot be fulfilled because we don't have enough repair capacity. Therefore, we will deliver out of the overall demand on that location 11.5, I would say we rounded to 12 pieces of the new product instead of the remanufactured product. So that is what the system is doing out of the box just by maintaining this remanufacturing supersession. And we exactly see it on the new product as well, which is its successor. So if we go to that DRP matrix of that product, we will see as well the indication that here, well, I need to, why I don't see it in April, no, I want to go back. I was wondering why I'm not seeing that in April. If we open up the demand, oh yeah, I do see it in April as well. So here on the successor product, we see that we have an overall demand for that product, and some bits of the demand in those months are not coming from the demand for that product. Those demand is coming via a substitution order, because we cannot fulfill the demand for the remanufactured product by remanufacturing. We need to procure some bits and bytes of that demand via the new product. And that is exactly what the system is showing us here. Now, I'm happy to hand over, Frank, to you to give us some nice outlooks, which I'm looking for as well.
Yeah, thank you very much, Frank, for the great demonstrations you showed and your insights how our customers can use our eSPP solution to improve sustainability and save investments. Now I'm happy to share some insights from the roadmap related to today's session. Since these are future-oriented statements, short reminder on our well-known disclaimer, and you see it right now, please bear in mind that these are roadmap items and SAP reserves the right to change them at any time without notification. But now let's really have a look at that. So our roadmap overall, it's also available at roadmaps.sap.com. And there is a small search window. When you put in there the capability service parts planning, as it's written also on the slide, you will see pretty much exactly what you see on the right side of the slide, meaning it gives you an overview of all our planned innovations. By now, it's not only about Q4 2025, because this is what we have delivered already just a couple of weeks back, but also what's planned for Q1, and since today, also for Q4 and the product vision of 2026. So, and as you can see, we do have many items on the list for the release also next year, 2026, and we have had a lot of topics also for 2025, which we just delivered. And I just would like to highlight a couple of them related to today's sessions. So especially in regards to inventory planning, as we looked at the multi-stage optimization, and then also on a cross-application topic around retail level planning, because as Frank pointed out, getting data and parts back from the dealer, from the customer level, allows us to also really save money, save investments, and do a repair or buy decision in order to fulfill demand. But with that said, let's have a look at the first topic around inventory planning. So there, we basically shipped now a couple of weeks back the possibility to calculate and also consider lead time variability in safety stock calculations. Now, this feature is available to evaluate the transportation time both between a supplier and the entry location, so externally into our network, as well as between the locations in our network, in our BOD. So for both, it's possible to analyze and report on lead time variabilities, and you see that on the upper screenshot of that slide, where you can really see, okay, what were the different lead times observed based on real transactional data in the background of the system, and how much variance do they had in, and to report on that and measure your suppliers as well on it. But it's not only this, to evaluate suppliers and how well your lead times are that you have in the system, but it's really also about using that information to safeguard your parts delivery to your customers. Meaning we include that and consider that in our inventory planning processes when we do, for example, the multi-stage calculation that Frank showed earlier today. And we do actually calculate supply variability share, which you can see on the lower half of the screenshot, where the safety stock contribution coming from that lead time variance is really directly depicted, so that you can either talk to your supplier or check for your internal transportation times in order to improve that if this is a large amount of safety stock, and therefore saving again money without losing any service level towards your customers. So, okay, besides inventory planning, we do have also enhanced with retail level planning. So when we look at our network overall, and you see that here on the left side, the complete network picture, a digital twin of your actual physical situation at many OEMs, where the last mile, so to say, the customer level, was missing so far in eSPP. And some of you who might have worked or seen the old APO SPP solution, we had a feature there to cover also this customer level. And this we brought back in together with some significant enhancements. Now, what does that mean? Now we allow to plan really on the network level, including this retail level. And this helps to get better inputs, excuse me, from dealers that can then be considered, for example, in the repair or buy function, but also to reduce bullwhip effects and to get a much better overall inventory planning in the network overall. So also for the retail level planning, we follow the typical eSPP processing of capture demand, forecasting, inventory planning, etc. However, since these dealers are typically a separate legal entity, there are specific points during the process where they can interact and take decisions. And we also need some additional informations like sales history, stock levels, in transit data, which they can be integrated via state-of-the-art SAP XML interfaces. And then the dealer can really take decisions along the planning process and sees the stocking list, what planning parameters went into the overall planning, and can take decisions for stocking and destocking suggestions, as well as replenishment proposals to agree on or not. Additionally to what the dealer can do, and that's typically integrated to the dealer via APIs to OEM-specific dealer front ends that we typically see in the market. There are also many new Fiori apps in order to support in monitoring for master data, for super sessions, etc., but also for taking actions like approving stocking, destocking proposals or replenishment proposals. And last but not least, as dealing with an external partner, there is also an emphasis on logging and evaluate, okay, what has been happening in the past, so that you can always see historical decisions and how it came to that decision. But with that, enough about what we have shipped just 2 weeks ago, and let's have a look a little bit into the future, what we are planning to do. So again, you see many items that we have. So SAP is overall still heavily investing in the solution and bringing out new innovations with every release cycle that we offer. So, but related to today's webinar, let me highlight a couple of items specifically. So when we look into inventory planning and the cost optimization we plan to offer with the next release in our solution. Now, what is this about? Frank, maybe you can. So when we look at the inventory optimization that Frank just showcased a few minutes ago, this is what we call a traditional inventory optimization approach, meaning we are focusing primarily on stock holding costs in order to take decisions where and how much safety stock to put into our network. However, the reality is more complex because for most of our customers, having a part not in stock when the customer asks for it doesn't mean that the business is lost, but in many cases, it's all about getting them the part from another location as quickly as possible. It's a much wider picture, and we actually need to consider also additional factors like what's the transport, like airplane, ship, etc., trucks, and the costs that are related to that, and also all the handling efforts and costs related to orders that are being fulfilled, especially if this is via an emergency order where the handling must be very quickly and where maybe special means of transport like an airplane or helicopters are used as well. So it's much more important to have a holistic service-driven cost optimization that considers still the network, but also considers additional cost elements. And what you see here is we've enhanced on the input side a lot of our factors that we are not only looking at stock holding costs, but also at the different transportation cost rates and handling cost rates, as well as some additional input criteria in order to come up with a cost optimal solution, considering, for example, parameters like minimum and maximum target service levels, because the target service level then becomes not an input, or is no longer an input, but actually becomes an output with that new optimization. And as a short preview, already further ahead beyond the next release, we are planning to even allow for certain stocking and non-stocking decisions in a certain boundary. So from that perspective, giving our customers an even better possibility to save investments and achieve high service levels, considering cheaper budgets. So beyond that, we also understand that it's very important to look at data on an aggregated level, and therefore we are also planning to offer new additional embedded analytics in our solution. And what you see here is a preview of a new safety stock analytics app that we plan to release next year. Of course, this one is supporting all different planning modes, meaning the single stage and the multi-level that Frank just showed a few minutes earlier, but also this planned new multi-level cost optimization that I talked about. Also, it will cover retail level safety stock data if you actually really use retail level planning. And we distinguish different scenarios, if it's safety stock projection or safety stock drivers, in order to analyze that further. Now, what does that mean? That means actually that you can really, based on customizable filters, really look at, okay, how does the safety stock projection look like overall, either for my whole location, for example, or maybe for a subset of my portfolio based on product group selections, or our new cluster type selections, meaning selections considering part location level. But not only have a look at it from an overall aggregated level, but also the option to drill down in order to get further insights, like which parts are the main contributors, either in quantities or in monetary value for those safety stocks, and where would it make sense to maybe look at it? How can I further save money and reduce safety stock when I then further analyze the drivers? Where is the safety stock really coming from? And as this is also covering a lot of different, will be also options for users to customize the view out of many key figures and data that you can then really select how you want to look at that. And we don't stop there, but actually we want to offer more embedded analytics in the future. So we are also looking at so-called booklets to be able to give further analytics insights from a top-level view into service parts. And you see here some design thinking examples how this may look like. However, please be reminded, this is a roadmap item, so those, especially those screenshots that I show you here now, they may or may not look like that when we actually ship them then later. So now, from that perspective, with that short overview, back to you, Frank.
Yeah. So thanks a lot, for Frank, for all the insights that are going to come. Hope you enjoyed the webinar. We are a little bit above the planned time, but 6 minutes. Hopefully, it's fine. Thank you for attending. When you have further questions, please reach out to us. We will answer the Q&A posts after that webinar. And as said, this webinar will be publicity accessible via our homepage or YouTube later on. And special thanks to you, Frank, as well, to participate and contribute here to our Westernacher webinar. Frank, last words are with you.
Allowing me to participate, Frank, and thanks for all our listeners. So please feel free, as Frank said, to reach out to us with questions. You see our contact details here as well, so that we may help you in your questions around eSPP. Thank you very much and have a great rest of the day.
Thanks a lot. Take care. Bye-bye.